All right, you're simplifying, you're not solving for anything. You're just making this look simpler, just like it sounds. So if you have the same base and you're raising it to an exponent multiplied, sorry, that wasn't a good explanation. This base raised to an exponent multiplied by the same base raised to an exponent means you keep the base and then you add the exponents. All right, so that's our first step. And that's all we can do because those are not like terms. A and 3, you can't combine them. So you're finished. Good. All right, so that's the multiplication rule. Remember, it's, how did we write it? A to the m times a to the n equals a to the m plus n. Is that rule? Sorry. All right. And then the next one is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So those are just two rules of exponents that we are applying to unique situation. So this is the same base of x, and then we're going to take all of 2t minus 2, and we're going to subtract all of t minus 5. Sorry, I didn't even put a subtraction, even though I said subtract. So here we added them, here we're subtracting them. 2t minus 2 minus t minus x. This is just a good math lesson. Distribute the negative sign, okay? 2t minus 2, nothing changes at first, minus t plus 5, because a negative times a positive t becomes a negative t, and a negative times a negative 5 becomes a positive 5. Good. Now you just combine like terms. Apologize. Excuse me. All right, combine like terms. What did you get when you combined like terms? You combined 2t and a negative t, and you combined a negative 2 and a positive 5, right? So you got 2t minus t is just 1t. Negative 2 plus 5 is the same as 5 minus 2 is the same as negative 2 plus 5, right? Either way, it's 3. So we get t plus 3 because it's a positive 3, not a negative 3. So that's the end of exponents. These sort of exponents will not be on the exam. All right, scientific notation. Also, sorry that if you printed off these notes, everything after this says that it's on page 5. I just tried editing my PDF in Acrobat and it's not easy. So these aren't very beautiful. All right. What we mean when we say scientific notation is that we are expressing a number as a product of any single digit number and 10 to a power. Okay. So we use it to express large quantities or small quantities. These two are very big numbers. These two are very small numbers because here's the decimal point for the small numbers, and then here's the decimal point for the big numbers. Good. So if you have 76,300 and you want to express it more in a different way, we'll say, what you can do is you can say that 76,300 is the same as 7.63 times 10 to the 4th power. Because, think about this, 10 to the 4th power is 10,000. So what we did is we took 10 and we multiplied it by itself 4 times, right? And anytime you multiply something by 10, you're basically just adding a 0 behind it, right? Oh, I'm sorry, you couldn't even see what I was doing. Anytime you're multiplying by 10, you're adding a 0. So I had 10, I added 1, 2, 3 zeros. So when I add 3 zeros to 10, I get 10,000. And I can also write that as 10 to the 4th because I'm multiplying 10 by itself 4 times. Good. All right. What it means is that this is my original number, and scientific notation has to do with your decimal point. Okay. So what did we do to the decimal point to go from 76,000 to 7.63? we moved the decimal point to the left, right? Currently it's right here. I moved it 1, 2, 3, 4 places to the left, right? We moved it 4 places to the left. So we could get 7.63. And then those 4 places we moved to the left means I raised 10 to the 4th power. Okay, so you're moving your decimal place so that the decimal point is after the first digit. Okay, so you'll see that in scientific notation, you always have one number in front of the decimal, no more and no less. One number in front of the decimal. You could have a ton of numbers after the decimal and then 10 to a certain power. So we're always choosing to put the decimal point right here. Here, we're going to put the decimal point right here. Here, the decimal point's already there. We're going to put it right here. Here, we're going to put it right here. Good, because we want the decimal point to be after the first non-zero digit. We want a single digit number right here. So how many places do we have to move the decimal? We had to move it 4 to the left. If you are moving your decimal point to the left, you are creating a positive exponent. Good. If we have to move them to the right, like here, we will move it 3 to the right. Negative. Okay, so if you're moving your decimal point to the right, your exponent's going to be negative. If you move your decimal point to the left, your exponent's going to be positive because this is a big number. So to turn this into a big number, we multiply it by 10 to the power of 4. So 10 with 3 zeros behind it. This is going to get bigger because it's going to be multiplied by 10 with 5 zeros behind it. 1, 2, 3, sorry. Good. But if we want this to become small, we are going to multiply it by 10. What happens when we raise it to a negative power? Oh, sorry. Okay, my calculator. Basically, you get a very, very small number because that's the same as dividing by 10 to the power of positive 5, right? We know that from the exponent rules. 10 to the power of negative 5 is the same as 1 over 10 to the power of positive 5. So your exponent's going to be negative if you have to move it right. So let's see how far we had to move this one. Currently, it's right here. And we're going to move it 1, 2, 3, 4, 5 places. And I moved it right? When I move my decimal point right, I make the sign negative. When I move my decimal point left, I make the sign positive. I kind of skipped this guy. So this guy, the decimal point's right here. I'm going to move it 1, 2, 3, 4, 5, 6 places. And I moved it to the left, so that's a positive 6. Good. Here, we just have the number 0.009. We're going to change it to the number 9. So how many places did I have to move my decimal point? My decimal point is, I'm going to rewrite it, but that's a bunch of trouble with this pen. All right, my decimal point's right here. I have to move it 1, 2, 3. Don't stop until you have one number, one non-zero digit in front of your decimal point. Okay, so I moved it 3 right. If I move it right, my sign is negative. Good. All right, so those were just examples. Let's describe a little bit what we already just did. To write a decimal number in scientific notation, the decimal number means it is a small value, right? Move the decimal point to the right, placing it after the first non-zero digit. The exponent of 10 will be the number of places the decimal point was moved. It will be negative. Are you kidding me? It will be negative because it was moved right. Okay, that's what I want you to take away from scientific notation today. Oh, Courtney, welcome. Sorry, it took me that long to read your message. Okay, so it's negative if you move it right. If you see a very small number and you're changing it to scientific notation, make your exponent negative. How many do we have to move this? 1, 2, 3, 4, 5, 6. Stop after your first non-zero digit. That's what this means, okay? All of these are zeros. Stop after your first non-zero digit. So how far did we move? 1, 2, 3, 4, 5, 6. Okay, we moved right, so we're making it negative. So it's 7.23 times 10 to the negative 6th power. If you're doing it in reverse, remember that this is a very, very small number. Okay, so you're going to start with 4. The decimal point is after the 4, and we need to move it 8 places. Okay, 1, 2, 3, 4, 5, 6, 7, 8. My decimal point is now right here. There's nothing in front of it. And how many zeros did I have to add to move it 8 places? I think I had to make 7 zeros in front of it because that was the 8th place, but we moved it 8 forward, so there should be 7 zeros in front of the 4. It's much smaller than 4, right? Because it's raised, multiplied by 10 to a negative 8. Good. So 0.000987 is the same as 9.87 times 10 to the negative 5th. Because our decimal point was here, we moved it until we got past the first digit, the 9. We had to get past the 9, so that was 5 times we moved it. Okay? 2 times 10 to the negative 9th is just like this one, so you have 2, the decimal point's behind the 2, and we have to move it 9 places. And count how many zeros are in front of it, right? And it should be 8, because that 9th place is the 2. Is that okay? Interrupt me with questions. Now, to write a whole number or a big number in scientific notation, it's the same thing, but it will be positive because it was moved left. Okay, so from a whole number is a bigger value. It's too big to write, so we want to write it in a little bit easier fashion. Okay, move the decimal point to the left, placing it after the first digit. The exponent of 10 will be the number of places the decimal point was moved. It will be positive because it was moved left. So here, here you go back until you have gone past 0, right? Here you go forward until you get all the way to the end, okay? Don't just stop at 3. Don't stop after 3. Go all the way to the last digit. Make that into a single digit number. See how right now it has, I would call this a 7-digit number. You know how they're like, oh, you get paid 6 figures. That means you get paid hundreds of thousands of dollars. So these are figures or digits. You want to go until it's a single digit number. Right now it's a 7-digit number. Okay, so your decimal point is here. If you don't have a decimal point, you just add it at the end. How many did it take to get it up to the behind the 7? 1, 2, 3, 4, 5, 6. Sorry, 6. I wanted to say 7 because there was a 7 right in front of me. So it took 6 spaces to get behind the 7. So that becomes 7.23 times 10 to the positive 6 because we moved it left. It will be a positive exponent. 4 times 10 to the 8th means I take 4, the decimal point's naturally right there, and I move that 8 places back. 1, 2, 3, 4, 5, 6, 7, 8. So that looks like 4 zeros. I'm very bad at this. My vision's too bad for doing a bunch of things, zeros all at once. 0, 0, 0. Good. All right. You can also if you're getting confused, right, just put in 10 to the power of 6. Oh, that's a big number, so I should obviously be going that way, right? 10 to the power of -3, that's a small number. I should go the other way. Good. So if it's raised to a negative power, we're going in the negative direction on the number line. And if it's raised to a positive power, that means we're moving the decimal point positively on the number line. That's another way to think about it. Yes. No, don't apologize. That's fine. Have a good day. All right. So let's practice. Let's practice. This is a small number, right? So I'm going to move the decimal point right. Remember, right, negative. Good. I'm moving it right. So my exponent will be negative. Start it here. 1, 2, 3. Stop it after you get past your first digit. So 1.25 times 10 to the 3. Since I moved it right, it's a -3. Good. Here I have a very big number, so I know I'm going to move it left. Left is positive. So here's my decimal point. I'm going to start moving it left. 1, 9 places, right? So that will just be at the 2. There's nothing behind the 2 times 10. I moved it 9 places and I'm keeping it positive because I moved it to the left. 2 times a very big number will give me a very big number. 1.25 times a very small number will make that 1.25 even smaller. 796,000. You're going to start here. You're going to the left, right? Positive. 1, 2, 3, 4, 5. Good. So that becomes 7.96 times 10 to the 5th. You can even do it with hundreds. You can do it with the number 90. Here's my decimal point. I need it to be a single digit number, so I'm going to move it 2 places. So it's going to be 8.72 times 10. I moved it 2 places. I moved it to the left, so that's a +2. Okay. 90, you can still do it. It's 9. You don't even need to put 0.0. You can just say 9 times 10. I moved it 1 place, so it's just 10, but I moved it to the left, so it's positive. So it's 9 times 10 to the 1st or 9 times 10. Good.
Could you put the scientific notation into the calculator and still get the same answer?
Can you put, oh, that's a good question. Like put
8.72
times
10 to the 2nd power. If you were to put that in there, would you still get yes, you still get the same answer.
You do, but as they get bigger, your calculator starts, I wish I knew my calculator better. But your calculator starts doing things for you and saying things like this. It just means you need to move it 6 decimal places. So it starts doing that for you. But I think you can turn that off. I should learn how to do that. But yeah, sometimes. You can definitely put it into yeah, you can. Let's see, 1.2, let's do this one. 1.25 times 10 to the power of -3. Yeah. Oh, sorry, you couldn't even see that. So yeah, it won't do it for like the 9s. If it gets past 8, I don't think it's gonna do it past 8 places because my calculator doesn't treat past 8 decimal points. But that's a very good question. All right, now they want us to express this in scientific notation. It's already in scientific notation, but not absolutely the best form of scientific notation. So let's take it. 27 times 10 to the 3rd means that's 27. My decimal point's here. I have a positive decimal point, so I'm going to add 3 places, right? 1, 2, 3. Now my decimal point's here. I added these zeros, and you can check that. 27 times 10 to the 3rd is going to be 27,000. And then don't worry so much about this. They're never going to ask you this to put it into scientific notation. This is just a good exercise for putting it from scientific notation back. And then if you were going to put this into scientific notation, it wouldn't be 27, right? It would be 27,000. And then you need to go back to a single digit. So 1, 2, 3, 4. So we're going 4 to the left. So it's 2.7 times 10 to the 4th. And we went left, so it's positive. Good. So this one, 281 times 10 squared. So we have 281. My decimal point is here. 10 squared means I'm multiplying it by 100, right? So I'm going to add 2 zeros behind it. 281 times 10 squared, adding 2 zeros behind it. And then putting it back into scientific notation. Again, don't look at this as one problem. Like this is one thing they'll ask you on My Math Lab, and then My Math Lab might give you this and ask you to put it into scientific notation, just like we were doing over here. But they won't give you something that's they won't give you something like this and ask for scientific notation. So this becomes 28,100. For the decimal points here. How do I change this back to scientific notation? 1, 2, 3, 4. I had to move it 4 in, right? So now it's 2.81 times 10 to the 4th. I moved it left, so it's a positive 4. Should have made that smaller. Good. All right, this one's just counting again. So we have 0.00179. I'm just going to move it until I get past the first digit, which is a 1. So I'm going to be left with 1.79 times, how many times do I have to move that? 1, 2, 3. 10 to the 3rd, but I moved it to the right, and the right is negative. So it's 10 to the negative 3rd. Same here. I'm going to end up at 7.63. How many spaces did I have to move it? 1, 2, 3, 4, 5 times 10 to the 5th, but I had to move it to the right. So that's a negative.
So it's
5.
negative.
Yes. Thank you. All right, this is another one like these. Don't get scared. 367 times 10 to the negative 3. So my decimal point's here. Negative means I'm making it smaller, right? 367 times 10 to the negative 3 means I'm putting it all behind the decimal. So I'm moving my decimal point to the left 3 places. I'm undoing the positive, the negative exponent by saying that that is equal to 0.367, right? Or I'm putting it in my calculator and seeing that. And then they want it in scientific notation. So that means now I just need to move it 1 over, right? And then it becomes 3.67 times 10. We only moved it 1, but we moved it to the right. So it's a negative 1. And again, you can check that in your calculator. 3.67 times 10 to the negative 1st power is 0.367. Good. All right, so that is scientific notation. Now we're going to do 5.2, more exponents and scientific notation if we have enough time. Yeah, I'm going to keep recording. Okay. Remember, you can watch these videos, but if you're trying to catch up over more than one day, you can also just watch the videos that are listed as 5.1, 5.2, etc. You should be able to find those as well. Okay. the power rule and the power of a product or quotient rule for exponents. This looks intimidating. Let's review what we know about the rules for exponents. We know, I know I've already done it once, but a to the power of m times a to the power of n is a to the power of m plus n, right? A to the power of m divided by a to the power of n is a to the power of m minus n. We know that anything raised to a 1 is, no, I knew I was going to do it wrong. Anything raised to 0 is 1. Don't make my mistake. We also know anything raised to the negative power can be turned positive. If it's negative down here, it becomes positive by putting it on the top of the fraction bar. Good. All right, so this is what we know right now. We've already learned this in 5.1. Now we're just adding that if you raise a base to a power to another power, you're not going to add them. That's not the same as multiplying them. Okay, that means you're taking maybe 5 squared is, oops, 5 squared is 25, right? So if I was going to say 5 squared times 5 squared, that's just 25 times 25, right? But if I say 5 raised to the power of 2 raised to the power of 2, well, 2 plus 2 and 2 times 2 are the same. That was the worst example ever to give. All right. I just want a small number. So 3 to the power of 2 is 9. 3 to the power of 3 is 27, right? 9 times 27 is 243. So, sorry, 3 to the power of 2 times 3 to the power of 3 is 243. But 3 to the power of 2 raised to the power of 3 is not that same value. Okay, you're taking 9 and you're raising 9 to the third power. Sorry. Three. All right. 3 squared to the third power is 729 because 9 to the third power is 729. I got it now. And 3 to the power of 2 times 3 to the power of 3 is 243. So those are different. Basically, what I want you to understand through all those mistakes is that these are different values, okay? You're multiplying them when you're raising a power to a power, and you're adding them when you're multiplying 2 powers. Good. Power of product rule means we distribute. So we take that n, we apply it to the a and to the b. So ab to the power of n is the same as a to the power of n times b to the power of n. A divided by b raised to the power of n is the same as a to the power of n divided by b to the power of n. So as much as it looks complicated and as much as I just in front of you tried to overcomplicate it, all it is that we're distributing and it's not the same as multiplying. Okay. All right, let's practice it. Use the power rule to simplify each expression. Write each answer using positive exponents only. So our rule is, let me get the letters right, a to the power of m raised to the power of n is a to the power of m times n, whereas on Wednesday we were adding them, okay? So now we have y to the power of 2 times 8, not plus 8, because it is a power raised to a power. 2 times 8 is just 16. So that's y to the 16th power. B is 3 cubed to the 2nd power. So that means we have that base of 3 raised to the power of 3 times 2, which is the same as 3 to the power of 6, right? That's okay. If it's kicking you out, feel free to just watch the video. Don't worry. All right. 3 to the power of 6 is the same as, all right, here's me trying to do this again correctly this time. 3 to the power of 3 raised to the power of 2. Good. Because 3 to the power of 3 is 27. 27 to the power of 2 is 729. And that's the same as 3 to the power of 6. Good. All right, 6 squared to the power of -1. That means you have a 6 to the power of 2 times -1. 6 to the power of -2, because a positive times a negative is a negative. Yeah. And then you never end with a negative exponent. So remember our rule. A to the power of -m is the same as 1 over a to the power of +m. So you create a fraction bar and you move it across the fraction bar to make your exponent positive. Good. All right. So 6 to the power of -2. Again, I'm going to just invent a fraction bar. There's a 1 under here and a 6 to the -2 up here. I'm going to move that across it and I'm going to put 1 on top, 6 squared on the bottom. You can further simplify this. Yes. And Courtney, if you, yeah, you can just watch 5.1 and 5.2 separately. It might be smoother. 1 over 6 to the power of 2, which is 1 over 36. Right? Because 6 times 6 is 36.
All right, thank you.
Of
Yeah,
course.
yesterday they said I wouldn't get my computer for another week, even though they said it was going to be done 5 to 10 days. Now they're saying another week to get it
No.
back.
Yeah, I'm
Yeah.
not surprised at all. That sounds like France, honestly.
Yeah, but thank you. I will try to see if I can zoom in on Wednesday as well
Yeah,
and
try.
see the lecture. Okay, thank you. Bye.
Of course. Bye. All right, here we have x to the -5th raised to the -7th. So we would write that as x times to the power of -5 times -7. Don't move anything across the fraction bar because -5 times a -7, right? Becomes a positive number, becomes a positive 35. So that is just x to the power of positive 35. Good. All right.
Is there another example on here, like the one you did just now, like number C?
Sorry, what?
Is there another example on here that you could do? One like the one you just finished?
This one?
Yes.
Sure. I'm going to make one
Thank
up.
you.
Just with the
Sorry.
positive and no, it's fine. The positive and the
Yeah.
negative. All right.
Yeah. It's kind of confusing.
Totally. So you know that anytime you have a positive times a positive, you're going to get a positive number. Positive times a negative is a negative number. Negative times a negative is a negative number. Negative times a negative is a positive number. Getting ahead of myself. And it doesn't matter the order. So that's just the general multiplication rule that is always true for all of math, right? So if you know you have one positive number and one negative number multiplied by each other, your answer is always going to be negative. So if you have q to the -5th, all raised to the positive 4th power, what you're going to do is you're going to, according to this rule, you're going to keep the base and you're going to multiply that number times that number. It doesn't matter if you're going to say -5 times +4, or you're going to say +4 times -5. The order of the multiplication doesn't matter, but the signs matter. So this was a negative, this was a positive. Negative times a positive is always going to be negative, okay? 4 times 5 is just 20. Grab the base. q to the power of negative 20. Good. And then so we're combining three different things. This rule about powers, or about what would it be, signs, I guess, positive and negative signs when you multiply. This rule about raising an exponent to another exponent, and then the rule that a to a negative power is the same as that same a moved across the fraction bar and that negative power made into a positive power. So we're using
Thank
all
you.
three of these rules. Sure. So you end up with, so if we're using this rule, and these are rules that everybody gets wrong or makes errors with on the exam. So this is very good to do. So now you have a number, or sorry, a base raised to a negative exponent. So what you want to always do is, too many purples. What you always want to do is move it across the fraction bar. And that negative exponent becomes a positive exponent. If you had, let's do an even harder one. Let's do 1 over 5 to the third power raised to the negative 4th power. Good. So it's already on the bottom, but it's positive, but then it's being raised to a negative, right? So our rule is, if you have an exponent raised to an exponent, you multiply them. So we're just going to say this is 1 over 5 to the power of 3 times negative 4, right? So that's still 1 over 5 to the power of, what's 3 times 4? It is 12. And a negative times a positive is always going to be a negative. So it's actually a negative 12. 1 over 5 to the negative 12. Good. And I cannot have a negative exponent. So I'm going to use this rule. A to the power of negative m is the same as 1 over a to the power of positive m. We're already on the bottom of my fraction. So we're going to move it up to the top of the fraction. So 1 over 5 to the power of negative 12 is the same as 5 to a positive 12, because we moved it to the top of the fraction. And you can, here's where your calculator is going to start just like, oh no, there we go. So that was fine. 5 to the 12th was our answer. And let's see if we were right. 1 divided by 5 raised to the power of 3 raised to the power of negative 4. Oh, sorry. I was out of camera angle. So you can see that those are the same numbers. So whatever your answer is, you can always plug that into the calculator and try to put in what they gave you into the calculator as well. If it's a number, there's a lot of opportunity for mistakes, as you saw me making mistakes with the calculator today, and parentheses as you get more complicated. But basically you're applying these three things. What's going to happen when you multiply them with the sign? What is the rule? And then what do you do with the negative? But yeah, I'm happy to. And if you ever leave class feeling like I need more examples of X, just email me just a brief sentence. I need more of example 1 with negative exponents. I need more of, or you can like draw a picture. All right. And I think it might come up again. Use the power rule to simplify each expression, write each answer using positive exponents only. So same thing. Here, the power rule means we just apply that 3 to both the 3 and the x to the 4th. That means we have 3 to the 3rd and we have x to the 4th to the 3rd, right? 3 to the 3rd, you can just put in your calculator. We've done it a couple times today. It's 27 because 3 times 3 is 9, 9 times 3 is 27. Now we have x to the 4th raised to the 3rd power. So that means we're going to multiply 4 times 3. So that becomes 27 times x. 4 times 3 is 12. So I got 27x to the 12th. Good. B, now we are using the quotient rule. So we're just going to distribute that 2 to the 4 and to the 5. So that's 4 squared over 5 squared, which is 16 over 25. Good. So if you put 16 over 25 into your calculator and you put 4 divided by 5 raised to the second power, and you put 16 over 25, you should get the same answer. Good. All right, here we are doing what we did here and here combined, right? So we're going to say 2 to that 4th power, x to the 4th to that 4th power over 3 to the 4th power times y to the 5th to that 4th power. Good. You can just put that into your calculator. 2 to the 4th is 16. X, you have a power raised to a power, so you're going to multiply them. 3 to the 4th, I think, is just 27 times 3. 81, sorry. Y to the 5th raised to the 4th means 5 times 4, right? So now you have 16, x to the 4 times 4 is 16, over 81, y, 5 times 4 is 20, right? And you kind of want to look at these and make sure you can't simplify them, which I know is a lot, but we can practice simplifying them. So make sure that you can't simplify this and that there are no like terms. Like if it was x to the 16th over x to the 20th, you could simplify that. But because those are different letters, you cannot. Good. Here, we're going to take that 2 and we're going to apply it to the -5, the x, the y, and the z. So the negative goes with the 5, -5 squared. That negative is being multiplied by all of these positive, or it's like all of this is negative, so you only need to give the negative to one of the terms, okay? We gave it to the 5. -5 squared, x to the 3rd squared, 7y squared, and z to the 4th squared. Any questions? All right, that -5, remember, a negative times a negative is going to make you a positive number. That is why anytime you have a negative raised to a second power or any even power, it becomes a positive number. So that actually becomes a positive 25. X to the 3rd squared becomes, keep the base, multiply the exponents, x to the power of 3 times 2. Y squared, same thing. So you have keep the base, multiply the exponents, and then z, keep the base, multiply the 4 times the 2. Good. All right, so that leaves us with 25 x to the 6th, y to the 4th, z to the 8th. Here's just a quick summary of all the rules we have covered. I'm not sure. Do you think we can get through? Get through 2 more? We probably should try. Yeah, because I got us behind when I missed class. All right, so let's simplify these. We're taking 2 x to the 0 power, y to the -3rd, and we're raising it all to the -2nd power. Okay, that's the first thing I would do is I would distribute the exponents, right? Because think of PEMDAS, exponents is right after parentheses. So we're going to distribute the exponent through the parentheses. 2 to the power of -2, x raised to the 0 power to the power of -2, and then y to the -3rd raised to the -2nd power. Good. All right. 2 to the -2. We'll just call that. I'll just leave it the same, right? X to the power of 0 times -2, right? And then y the power of -3 times -2. Is that okay? All right, still leaving it as 2 to the power of -2. 2 to the power of -2, x to the power of 0 times -2. Anything times 0 is 0, so we're still just x to the 0. Okay, and then y, a negative times a negative is a positive, so we're y to the positive 6 power. Now I have 2 to the -2. Anything raised to the 0 power is 1, right? So what I have is 2 raised to the -2nd power times y to the positive 6 power. Good. There's one more step. What is my last step? My last step is I need this to be a positive exponent. So I'm going to put it on the bottom of my fraction and leave my positive exponent up here. Move my negative exponent down here. And then just, yeah, use mathematical reasoning to say what is 2 squared? It is 4. So we are done. All of that becomes y to the 6th over 4. Okay. All right, one more. X to the -5 raised to the -3rd over x to the -2 raised to the -3rd. They're all together, but we're going to distribute that -3. So we have x to the -5th to the -3rd over x to the -2 to the -3rd. That was just literally because I couldn't fit the -5 in there. So those were extraneous. They are not necessary. So that becomes x to the -5th times -3 over x to the -2 times -3. Okay, don't move anything around until you're done distributing, okay? -5 times a -3 is going to be a positive 15. -2 times a -3 is going to be a positive 6. So now we just have something similar to what we had in 5.1. And remember, when you're dividing exponents, you're subtracting them. So that actually becomes x to the power of 15 minus 6, which is x to the power of 9. Or if I drew out 15 x's up here and 6 x's down here and canceled 6 of them, I would still have 9 left over on top. All right, that is all I've got. Just want to, let me stop recording.